Hey guys, welcome back to another homework video. So today we're going to be going over homework 12, and this was another practice quiz. It was shorter than the other one, but it also had some free response questions at the end of it. So I'm going to go over every question and help you guys out in case there were any ones that you were confused about. Same as last time, I'm going to go through afterwards and make a pinned comment about the timestamp for every question, so you don't have to watch the entire thing if you don't want to. And yeah, so with that, let's just go ahead and jump right into it. So we're here on question 1. So this is a pretty simple question. It doesn't take forever to read. And so just asking, when you run the following line of code, what happens? And so a question like this, I would recommend doing it in your head. And then, obviously picking the answer choice that lines up with that. So it goes from left to right because this is all modulo, so there's no order of operations here because it's the same operation the entire time. So 5 modulo 6 is just 5 because, what's left over when you do 5 divided by 6? 5, because you can't go in like the whole way once. Your remainder is 5, and then so that takes care of that, and then so then we get 5 modulo 7, because 5 modulo 6 is still 5, so 5 modulo 7 again is 5 because 5 is less than 7, so your remainder, if you try to do 5 divided by 7, is just 5. So if that doesn't make sense to you, a helpful tip when you're doing modulo is that if the number on the left, so the first number, is less than the number that you're doing, like the number on the right, then your answer is just going to be the number on the left. So 5 modulo 6 modulo 7 is 5, and oops, go all the way back up. We have C, 5. Moving on to number 2. So we have, what is the output of the following program segment? So it just starts with int num is 5. We have system.out.print num. So the first thing we're going to do is we're going to print out num. And then after that, so we've printed out 5. We know that. We're looking for the output. We have 5. And then, well, num is greater than or equal to 5. Num equals num minus 1. So is 5 greater than or equal to 5? Yes, it is. So num equals num minus 1. Now it's 4. Is 4 greater than or equal to 5? No, it's not. So then we're going to move on to the next line, which says print out num. Num is 4. So we get 5 and 4. Let's make sure we're correct. We are. Look at that. So then, go on to the third question. This one took me a couple minutes to do when I was in class. So for questions like this, especially questions with arrays, especially questions like this where you have a bunch of like reassigning of things, I would recommend getting out your scratch paper again. Let me do that real quick. Hold on. Okay, yeah, so this is our one from last week. I'm just going to keep using it. So when you see, like I was saying, a whole bunch of reassigning statements, I would recommend using our scratch paper the way we did last week. So what order of variables here? We have nums, which is 5, 2, 8, 3, 4. So nums 5, 2, 8, 3, and 4. And then we have, just move these tabs, k, which is nums.length minus 1. So if nums.length is 5, k is 4. K equals 4, right? And then RPN is 0. RPN equals 0. So now, while k is greater than 0 and is 4 greater than 0, yes it is, so we're going to go into this loop. Int temp, so that we get another variable here. So we have temp is nums of k. So it's the nums of k. And we said k is 4, so 0, 1, 2, 3, 4. It's the last one here, which is also 4, so temp is 4. And then, so we do nums of k. And the next thing we do, nums of k equals nums of RPN. So we have nums of k, which is the last one here, becomes our nums of RPN. So we have nums becomes 5, 2, 8, 3, and then we're changing the last one, we're changing it to the first one, so we have 5 again. And then last thing, we have nums of RPN equals temp. So we're reassigning another value in nums. So we have nums of RPN equals temp, so we just switch these here. See, because 0 and then temp we held it is 4. So now we have, this is our new one. So then k minus k equals 3. I think RPN plus plus. Yes, RPN plus, so RPN is now 1. And then temp we haven't done anything to yet. So is k greater than 0? Yep, it is. So we're going to do all of that again. So int temp is nums of k. Oops, let me just go over there. Temp equals nums of 3, so 0, 3. It's 3. Nums of k. And if you can see the pattern that's going on here and you think you can answer this question based on what I've already shown you, fantastic. If you need to keep going, like I always needed to go all the way through. That was me. I always needed, these questions always took me a long time because I always needed to go all the way through because I couldn't really see it until I'd run the entire program. So nums of k, so that's, you said is nums of RPN, so that becomes 2, right? And then nums of RPN equals temp. Okay. And then we subtract from k. RPN we add 2. So now they're the same thing. And we're going to change temp next. So k is still greater than 0. Temp equals nums of k. So temp equals 0, 1, 2, 8. So this one, we do nums of k is nums of RPN. So 4, 3, and then nums of k is the same thing as nums of RPN. So we reassign it to 8, but it doesn't actually do anything this time. And then again, nums of RPN. So 0, 1, 2 now equals temp, which again is 8. So this one still doesn't change anything. But we're still going. So we have k equals 1 and RPN equals 3. And then we're going to change temp in a moment because k is still greater than 0. So we have int temp equals nums of k, which if k is 1, it's 3. And then nums of k equals nums of RPN. So nums of k, 0, 1, 4, nums of RPN, 2, 8, 2, 5. Right, 4, 2, 8, 2, 5. Yep. And then we have nums of RPN equals temp. Sorry guys, this is pretty slow, but 1, 2, 3. And then I believe, so now we do k equals 0, RPN equals 4, temp equal, but look, k is no longer greater than 0, so we're out of the while loop, so we don't change temp anymore, and there's no more code after that. So this is what nums finally looks like. This is what k is, and this is what RPN is when we're finally done here. So after the shuffle method is called, what element will be contained in nums of 4? Let's go take a look. 0, 1, 2, 3, 4, and the answer is 5, which is A, and look at that. So for a question like this, I always have to go all the way through on scratch paper. If you're one of those people who, like the second time I ran it through, you could see the pattern, you could see where this is going, that's great. But if you need to go all the way through, that's absolutely fine. There's nothing wrong with that. Just, make sure you're careful with reassigning all this stuff, and then, yeah, so there you go. Okay, question 4. Let me go to it on here. Question 4. All right, so we have another question about contents of an array. And so this one, we have an int array. It has 10 things in it. Int I is 0, and then, I is less than jo.length. So this, I had to read it. The first time I looked at this, I was like, what? The answer doesn't make any sense. But then I reread the question. I was like, oh, it's because I read it wrong. This one you got to read really carefully. And generally, like obviously throughout the entire test, you have to make sure you read everything really carefully. Because in code, like you've seen it yourself whenever you're looking for errors and you find out it's because you missed a semicolon. Like Java's really picky about the way that you write stuff. So gotta be really careful with the way that you read the questions and the way that you read all the problems. So anyways, let's just go ahead and jump right into this. So we have an int array right now. Everything is null. or it's not filled yet, which means that they're all zeros. They're all zeros. If you have a number array and you don't fill them, originally they're all zeros. So we have 10 zeros right now in an array. And then int I is 0. So we have a while loop while I is less than joe.length, which is 10. Then we're going to do if joe, and this was the part that I read incorrectly. So we're looking at I modulo 3 in joe. So right now I is 0. So 0 modulo 3, and like I was talking about earlier, because 0 is less than 3, 0 modulo 3 is just 0. But that's not what we're comparing. We're looking at what is inside joe of 0, right? And like I said, we haven't assigned anything to those yet, so they're all zeros. So joe of 0 is 0. So that means that we're going to fill joe of I, which is also joe of 0, with 10. So now we have joe of I, joe of 0 is 10. Let me go ahead and write this out. So right now we have, let's say we had 10 zeros. 1, 3, 4, 6, 7, 8, 9, 10. 10 zeros. Now we have a 10, and all the rest are still zeros. So then, okay, so we've hit that if statement, which means we're not going to go into the else. Otherwise, we just set it to 5, and then we add 1 to I. Okay, going back up, 1 is less than 10. So we go through, we look at here. If I, or joe of I modulo 3 is 0. So let's see. 1 modulo 3 is 1. Is joe of 1 0? Right? It still is, because we didn't change it. So then we fill it with 10. So we have another 10. I'm building this array up here. Reassigning all the zeros. Don't go into the else statement. Plus plus. 2. If joe of 2 modulo 3. 2 is still less than 3, so we're looking at joe of 2. It still doesn't have anything in it, so it's still 0, so we fill it with another 10. Don't go into the else statement. Plus plus. Now here's where stuff starts getting interesting. If joe of 3 modulo 3, right? Now I is 3, because we have 3, 10, 0, 1, 2. Yep. So we have 3. So I is 3. So what's 3 modulo 3? That's 0. So now we're looking at joe of 0. Is joe of 0 0 anymore? No, it's 10. We already reassigned it to 10. Now we go into this else statement because this isn't true. And we say joe of I, so joe of 3 is 5. Okay. And then we do, so now we add 1, it's 4. So 4 modulo 3. What's left over when you do 4 divided by 3? 1. So is joe of 1 0? No, it's 10. So we're going to make this 5. Okay. 5 modulo 3 is 2. You can see where this is going now, hopefully. Is joe of 2, is that 0? Nope. Don't forget, I'm highlighting the third one. Never forget that the index of array starts at 0, so this is 0, 1, 2. And then so we have 6. 6 modulo 3 is 0 because it goes in evenly. There's no remainder. We already figured that's not 0, right? We filled it with 10 earlier. 7, a 1 left over, right? So we make it a 5. And then 8, there's 2 left over. Hopefully you're following me in this. I'm kind of going fast. And then 9, again, goes in evenly. So there's none, because these 3, 0, 1, and 2 are all filled. The rest of these are 5s. 9, and then I will not be 10 because 10 is not less than 10. 10 is equal to 10, so we end that. And then we have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So this is what our array is when we're finished. If you want me to redo this one and go a little slower than that, just put it in the comments, let me know, and I'll try to help you out. But this one for me, I was actually able to pick up on the pattern on. Hopefully the rest of you guys were too, so let's find the one we found. Found 3 10s in the front and the rest of them 5s, so that would be B. There we go. So yeah, that one took a little bit of, mostly you had to read this line really carefully, and once you read that from there, it wasn't too difficult, hopefully. But I went kind of fast on it, so if you want me to do a more in-depth analysis of questions like this, or this question in particular, drop that in the comments. Okay, moving on to the last multiple choice question, we have question 5. And I was talking to one of my friends in our period, and he was like, yeah, I hate questions like this, because they're so nitpicky. And I said, yeah, I get that. But I told him the good thing is that questions like this you can do in your head for the most part. when you have 3 different if statements and then 3 different return statements, usually you can do questions like that in your head. So let's actually read the problem, then I'll walk you through how I would have solved it if I was taking this test. So we have consider the following method biggest, which is intended to return the greatest of 3 integers. That's why it's called biggest. Again, if this doesn't make sense to you, just look at what the method header is. Generally speaking, they're helpful unless it's like mystery or something like that. It doesn't, so we're just straight up told it doesn't always work as intended. That doesn't mean there's an error in it. It probably means it runs. We just don't get the result that we want. But we're just told straight up, we don't have to figure that out for ourselves. It doesn't always work. So let's go ahead and take a look at it. So this looks pretty vague. We're given a whole bunch of variables, but none of them actually have any values. So what I would suggest for a question like this, look at the question and then go through the answer choices, because they will tell you what to kind of like substitute for these variables that can be literally any number in existence. So let's start with A. Biggest always returns the value of A. Can we disprove that? Let's say we make A 1 and B 2 and C 3, right? So if this works as intended, we should get C because it's 3. So is A greater than B? And then remember this and statement, they both have to be true. So if just one of them isn't true, we can move on. 1 is not greater than 2, so we move on. So is B greater than A? Yes, it is. And is B greater than C? No, it's not, because 2 is not greater than 3. So we move on, we return C. We didn't get A, so A can't be correct. We didn't get the return value of A. Alright, biggest may not work correctly when C has the greatest value. Okay, now let's make C 1. So we'll make B 3 and then A 2. So is A greater than B? No, 2 is not greater than 3. Is B greater than A? Yes, 3 is greater than 2. And is B greater than C? Nope. So we got B, which is what we should have had. So I think we can move on from there. Biggest may not work correctly when A and B have equal values. Okay, so let's make A and B both 2, and then we'll make C 3. So then, okay, let's do that. So is 2 greater than 2? No. Again, is 2 greater than 2? No. So we got C. We got C, which is 3. Alright, so that looks pretty good too. Biggest may not work correctly when A and C have equal values. So again, let's make these 2, and then we'll make that one 3. So is 2 greater than 3? No. Is 3 greater than 2? And 3 is greater than 2 again, so we got B. Alright, that worked correctly. B and C have equal values. So we'll do, okay, again, one more time, we'll make these 2 and that one 3. Is 3 greater than 2 and 3 greater than 2? Yep, we got A. So all of these work correctly. So what happened here, right? We didn't obviously check every possible scenario for these. So if you ever get a situation like this where they all seem to work correctly, maybe run it through with a different scenario. So for these ones, right? So this one can't be correct because it has the word always. So if we can prove that it will return something else, which we've done repeatedly now, it can't be this one because of the word always. The rest of these, however, say may not work correctly when C has the greatest value. So because of the word always isn't there, there could be circumstances where it just does work out where it returns it correctly, even though the program is kind of faulty. So for these 3 example, right, we always had the 2 that were the same be the lesser ones, right? Because we had 2 2s and then 1 3. So what if we switch it? What if we have 2 3s and 1 2? Let's try that for these ones. And then if that doesn't work, we'll go back and take a look at this one, right? So biggest may not work correctly when A and B have equal values. So if A and B are both 3 and C is 2, we should get either A or B because technically both of those are correct. If we get 3, then we're right. So is 3 greater than 3? No, it's not. So we don't even need to look at that one because of this and statement. And again, is 3 greater than 3? No, it's not. So we get C. We get 2, which we shouldn't get. So that's kind of questionable. Let's just check the other 2 just to make sure. So again, 3 and 3 and 2, right? So is 3 greater than 2? Yes, it is. But is it greater than 3? No, it isn't. Is 2 greater than 3? No, it's not. We can move on. Otherwise, we return C, which is 3, so that works out. We're good there. We got a 3. It may not work correctly when B and C have equal values. So again, these 2 are 3, and the other one, A, is 2. So is 2 greater than 3? No, it isn't. Is 3 greater than 2? Yes, it is, but 3 is not greater than 3. So we get C one more time, which is correct. So it looks like C is our answer, but let's take a look at B really quick. It may not work correctly when C has the greatest value. Well, for this one, you kind of just have to logic through it. You can't really prove it for sure. Like we've already proven that this one may not work correctly, which, you know, if you're pressed for time and you have a circumstance where this is, you know, you find a circumstance where this is true, go ahead and put that. But if you want to test all of them for sure, this one you're not going to be able to actually prove whether or not like 100%, because there are so many possibilities for all of them. For C having the greatest value. So for this one, you kind of just have to think it through. Like, if C is the greatest value, these if statements are never going to go through, because these two aren't ever going to be true. So you're always going to end up in this else statement. So this will always, B will always work correctly. So hopefully it makes sense to why the answer is C. And let's just double check that. Yep, we're good. Answer is C. So hopefully that makes sense. And again, if not, let me know down in the comments and I'll try to give a more, detailed explanation of that. Now, let's move on to the free response, which was probably the hardest part of this. Yeah, so these always look intimidating, especially long ones like this. The second one wasn't quite as long, but the first one was definitely long. It had a lot of words, and you had to kind of go through it and decide, what was important and what wasn't. So for this one, you definitely have to read through the entire thing, and especially this part. You have to read through the black part. You have, like the not italicized part. You have to understand what it is they're asking of you before you really get started. So now that's been said, let's do it. So we have a class car definition partial. We're being told to add a second constructor on our answer sheet, so in the Google form, to the car class. New constructor should allow the client to select the location of the car and the color of the car. So X, Y position. So that tells me that this constructor should have 3 parameters, right? An X, a Y, and the color. So then we have see the figure for example calls using the provided constructor and the new constructor. So let's take a look at this partial car class. So we have private rectangle R, HB. I'm not even sure what that's supposed to stand for, but that's okay. We know it's there. Wheel 1 and wheel 2. And so this is the original constructor that we're given, which this gives us int W and int Z. So we have the rectangle with W and Z. And then it's 50 by 20. That's how big it is, right? So wheel 1 is like this, and then wheel 2 is like that. So we can kind of come down here instead of having to figure out where this will be placed. It shows us what it looks like. And so we can see that with the new constructor, we're not supposed to be changing, the way that the car looks. So all of this is already set up for us. And then HB, which doesn't look to me like it's drawn. Let's take a look at the draw method. Oh, okay, this is the hitbox. That's what it is. That's the hitbox, because we can see down the draw method that it's not drawn. So HB is the hitbox. So this is just for like if you're going to make a collision method. Anyways, yeah, see. So understanding that is pretty important. So then now that we have all that figured out, so we have set color, which we can look at pretty quickly. It's pretty standard for setting color. We're just setting the color of all the variables except the hitbox because we're not drawing that. Draw, like I said, draw the parts. So we get this little guy down here. Fillet is for if we want to fill it all the way, and then get balances would be more specifically for a collision method, but again, we're not really concerned with that. And then this note down here that all methods are not shown. My dog just walked in. So let's go back to what we're being told to do. We're being told to add a new constructor that has the XY position. So it has everything that's already in this, right? This gives it an XY position. So instead of trying to like reinvent the wheel, yeah, you could write all of this again, but you don't have to. Hopefully you guys remember when you're doing all your constructors from your car class that there's a special method and it's called, a special command is called this. And so what this does is if you have, a constructor that already exists above that one, it'll call this, so what you've already written for the 2 variables that you put, or however many variables that you put in the parentheses. So if we have double X and double Y, right, it's going to look for doubles from the other, or ints from the other ones, and then So it runs all of this with X and Y. So it does the same thing with W and Z that it would do with X and Y. And then we have another line here, which is set color C. And this this string, I talked to Dr. He said that's not supposed to be there, so that's a mistake. Just ignore that. But we should have three variables, or three parameters. So double X, double Y for the X and Y position, color C. And then we're going to set color, and because set color is already a method in this class, you can call it in the constructor. And so that will set all of the parts to that you have now built, right? You've now made them so that they exist. It will set them to the color that the user wants. So yeah, only 2 lines of code to write besides the header. If you did write all of this again, that's not technically incorrect, but it's much more efficient to do it with this command. And so for the second one, this one's not quite as long, but in my opinion, I think it's a little bit more difficult to really wrap your head around, but that's just my opinion. So given the following PSVM, which if you didn't know, well, hopefully we all know it's what the user uses, but public static void main PSVM, right? Write the necessary code to provide the output shown for one run of the program. It should work for any value of string input by the user. So we're told tell the user to put in a word, create an easy reader, string W equals Joe.readWord, so it reads the word that they put in, only one word, not a whole line. And then we print out the reverse word is, and then here's our method, rev of W. So we're writing the method rev. That's basically what we're doing. So the necessary code would be rev because everything else already works as it's supposed to. So we want to reverse the word and then print it out with rev. So again, yeah, see, here's what I'm saying. So sample output, please enter your favorite word, anti-disestablishmentarian, that word that I almost pronounced, and then you reverse it and it's this lovely word salad. So let's take a look at how we're supposed to do that. So obviously, like I said, we create the header public static string rev because we want it to return a string, right? Because we're told to output this, so it has to return something, and you want it to return a string, obviously, because we're not turning around numbers. So we start with string rev word or whatever you chose to call this. And it's blank for now, but we have it, it exists. And then we run this for loop. I0, I is less than WW, which is whatever they put in, dot length, I plus. So we're just going, through every letter in there. Then rev word equals WW.substring I, I+1 plus rev word. So this line is really where it all happens, and this method took me almost an embarrassingly long time to figure out why this works. But the reason that this works is because, so we have rev word and we start with this blank, and then, so start string, if you remember, hopefully, it calls on the index, so this is the start index, and then this is the end index of whatever string you're looking at. So for the first time we run through, it's 0 to 0 plus 1, so it's 0 to 1, but that just ends up, the way that it works is it ends before the end index, so it just gives you one character. It gives you the 0th character. So I was looking at this and I was like, why are we looking at the first one, right? We're looking at the 0th index. We're looking at the first index of this word. But then I figured out it's because it puts this like first. So what it does is, so let's say we have the word cloud, which I have this example here because I needed to test this because I could not for the life of me figure it out. So we have cloud, right? So it goes through it the first time and it takes the C and then it puts it in rev word and then it adds the rest of rev word, which the first time is nothing. And then the second time it takes the L, right, and puts it in first and then adds the rest of it. So then it adds the C. So let me show you what I'm talking about, because I kind of modified it a little bit so it prints it some more. So here's what we have. So like I said, it takes the first one, and then it puts the L in front of it. And then it puts the O in front of the LC. And then, and then it ends up printing it twice because the way I wrote this. But that's the way that it works. Hopefully that makes sense. It takes the first one, and then the second one, but it puts them in front of each other. Instead of going from because the way that you'd write it otherwise is if we put rev word plus this, then it would write it forward. So yeah, that's how that works. Hopefully that makes sense. And if any of these don't, or if you want more explanation or more time spent on these, Ask Dr. Neat, ask the Super AP Junior Period, drop it down in the comments of this video. We're here to help you. We want you to do well in this test. So yeah, just, feel free to communicate about things like that. And hopefully you did pretty good on this homework. Hopefully this is starting to make sense to you. And yeah, Christmas break is coming up, so good luck with you guys' finals, if you have those. And yeah, we'll see you probably next weekend. I think after that we're on break, so good luck to all of us getting there. See you next time.